Hey everyone, welcome back to my YouTube channel VAST.U, and in the second video of the series in which we are learning how to create reusable Grasshopper scripts to detail out your architectural models. At the end of this video, you will have a script ready to detail out a curve in your architecture models or your urban design models. Now you just need two inputs for this script. One would be a curve edge and second would be a point of entry. So let's get started. So before starting the curb script, I'm going to show you one more quick use of the zebra crossing script that we did in the last video. And this is how you can use it to also create a lane division between the roads, because normally the textures that we apply off-road don't usually bring out these lanes, but this way you can create your own lane. So what you have to do is just click on the line that you have made here for the lane divisions, and one way you can do it is just right click and set one curve here, and now you can see we have a zebra crossing pattern here, but we need a lane division which is very thinner and more distance in terms of division between these stripes. So what we have to do is just scale set to 1, which will ensure that our start and end point, unlike the zebra crossing, are exactly at the start and end point of the curve. The second thing what you want to do is the half width, reduce it to, I guess, I don't know, right now I'm just gonna align it with this strip, but it should be around 0.1, I guess, normally, but then again check the standards in your city. So yeah, 0.1 seems pretty good. Now this already looks pretty close to what we have here, but we need to increase the distance by a little bit. So what we are going to do is increase the strip width, I guess. Yes, that's looking much better. And what we can do is just bake it. So yeah, this looks pretty close. Now again, you can increase the strip width numericals range from here, but I'm not gonna go into it because I guess you already have an idea. So I'm just gonna bake the geometry of here. Make sure you don't bake this geometry because it might bake some weird results, because we don't have those exterior lines anymore. So I'm just gonna right click and bake it there. And here you have these interesting lane lines on the road. So now let's move on to the curb. So I'm just going to open the script here. So this is what we are going to make in this tutorial. I'm going to upload a one more image of this script. Now there is not much of a difference between these two scripts. The only difference is, well, let me show you here. So let's say this is the edge of my curve here where I want a curb, right? So I'm just gonna isolate it for now so that we have clear view here. So I'm just gonna show you real quick, set one curve and points. So this is the point of entry, and I'm gonna set multiple points of entry here, which would be 1, 2, I guess here 3 and 4. Enter, and let's quickly see the results here. Yeah, so this is what we are going to get, a nice curb edge. Now of course this is the only reason that we are making this script, is to get this nice detail where the curve goes down and goes back up, because again, if we don't need that, we can just like offset and make extruded surfaces out of the curb lines. But this is one of the most important details that will bring out those aesthetics of this junction, you know. So let's see what I'm talking about. So this is the part I'm going to skip. Now this is just basically extruding this curve into a surface. Now the reason why I'm not going to show you, and I'm going to show you until here, is, let me show it real quick. So this is the final result that I'm going to show you, which is just basically a curve. Now you can do it manually where you are lofting the surface with the other curve, and the reason why I'm not going to show you is mostly you will never use this surface but mostly the curve. And let me show you why. I'll just go quickly open the curbing. Yeah, because what I felt while I was making my model was, sometimes you might need to add details like these planter, or you know, edge details where you might want to divide this edge and then separate the surface with this walking surface. So there are again much more edits that might be done manually later. So getting this whole thick curb is a single surface would not necessarily be the best option. But again, if you want that is a single surface, maybe you decided that, oh, it's a big urban design model and where you don't need to show all these small details and the view is going to be very zoomed out. So again, you can skip that and basically just copy this script, where you will, as a final result, you will get this as a whole one surface. But so yeah, let's get started. So I'm just gonna hide all this so that we have a clear view again. I'm just gonna hide this. I'm gonna hide this curving. Yeah, so this is the flattened curve that you might have from AutoCAD or Rhino or even Revit in this case. And so let's start with a simple curve input here. So I'm going to set one curve. Perfect. Now what we need to do is basically set one more input, which would be points. Sorry, just point. You don't need to write points, and set multiple points. But for that, let me just quickly set points here. I mean, I'm assuming it will be mostly on the edge of the curve. You know what? Let's keep one in the center, and I don't know, maybe here and maybe here. Yeah. So we have 1 2 3 4 5 6 7 entry points, and let's keep that. Now when you are setting multiple points, make sure you either go clockwise or anti-clockwise. This is gonna keep the script clean and make sure that you will have less errors in your Grasshopper. So make sure you go either clockwise selecting these points or anti-clockwise, so that you have this nice clean blue line which shows the sequence of the points selected. And I'm just going to enter this. Now the second step that you have to do is, let's start with the entry width of the curve. So to decide an entry width of the curve, we are going to make a circle CNR here. Sorry, we need these points here. Oh, before that I forgot to make sure these points, which are given manual points, you need to make sure these points are exactly on the curve, because sometimes what happens is, even if you're putting your points manually in Rhino, there is a little bit of error in that they are not exactly on that curve, and this might again create one more error. So let's play safe and let's create just one more thing before we start, which is the curve closest point. Curve closest point. Now this will ensure that every point that you have given is exactly on the curve and not even 1 millimeters or 0.1 millimeters outside of that curve. And this will help us not to get any errors at the later stage, which might create a huge problem at the end of the script. So again, now these points are exactly on the curve, and I'm gonna give the center is these points. Now the radius is basically the entrance radius of the curve. Now if you see the intersection between the circle and the curve here, this portion will be where the curve would actually flow down, touch the road, and then go back up. So it will come down here, go back up here smoothly. So we need to increase that. Right now it's 1 meter by default, so I'm just gonna keep it to, I guess, I don't know, 5, and we can change it later. Yeah, just for 5 seems good. So we want the curve to go down here and then go back up, and the same way on all the other points. But so let's keep it 5 for now, and we can change it later. The second thing what we want is now test points on the intersection of this, so that later we can separate this curve into separate parts, where we know that, oh, this line is going to be straight. Now this is where the slope is going to start, and then again this line is going to be straight. So let's do that. So what I'm going to do is basically curve intersect, curve. I'm just going to write curve intersect, I guess. Maybe I'll write intersect. Okay, let me just go manually and find it, transform, and curve. So this is a self intersection, like it will solve two intersection points of the of two different curves. So the curve A would be circle, and then curve B would be the whole curve of the curve. So now these are the points, there are the intersection points, and now we can basically move ahead and divide these portions of the curve, right? But before that, again, just to make sure that these points, I know it is already an intersection, but just to make sure that these points are again on the curve, I'm just gonna add one more curve closest point. I'm just gonna press Alt and copy it here, so the points will be here and the curve will be the same. And I'm just doing this because I've tried the script like multiple times and it sometimes create problems. It's weird, I don't know why, but this will help. So trust me, you need this one right now. Now what we are going to move ahead is we are going to put a point here, and now we are going to shatter this curve. Now shatter is a technical term in Grasshopper, but basically we are going to break this curve into different portions. So let's do shatter, and again the shatter will need parameters, so then this makes more sense to use curve closest point rather than just putting params A and params B. So the points, let's just flatten it for now, and what we can do is put the parameters here, and the curve that we want to divide is, let's say, if the same curve that is going here. Okay, now let's see the segments. Cool, we have 30 divisions, which seems perfect. Looking at, there are 7 points, so what we can do is now study the length of each point, and that will give us an idea of what to do next. So the length of each line, let's see. So now you will see a very I don't know how to say it, but very similar pattern in terms of the lengths of these curves, which are going to be our entry areas. Now here you can see it's 10.3, again 75, which would be like a longer one, again 10.31 something, 192, which would definitely be a straight line, on a higher level than the entry points again. So all these 10s that you see are possibly these entry lines, and we need to separate those, because then again what we will do is separate these lines and give them both different heights and basically make a smooth curve connecting all of these. So I'm going to show you, don't worry about it. As the script goes ahead, you will understand what I'm exactly doing. So let's delete this from here. And now how to say that, okay, we need to, how to convey to Grasshopper that we need all these lines separated. So if we tell Grasshopper, then anything, so wait, I'll go back, Control Z. So 10.3 is basically the double or the diameter of the circle. Now the diameter in this case would be 10 because the radius is 5, and 10.3 is less than plus 1 of the diameter, right? So anything less than plus 1 of the diameter would be these curves, right? Again, anything less than plus 1 of the diameter, so anything less than 10 plus 1, 11 would be these lines, and that is the maximum that we have and a common pattern between all of this. So I'm just gonna add an evaluate function here, just like we did it in, I think, in last video. I don't remember. Just gonna delete variable and variable because we just need x and y. So let's evaluate this. So x could be this and y could be the number that I am telling you, which is 11. Now obviously we don't need to put this manually 11, because again, you never know, you might have to change this later. So I'm just gonna multiply it by 2 so that we have a diameter. Is our answer. Okay, so the result is 10. Cool. And now plus 1, so I'm just gonna put plus 1. So again, addition will happen, plus 1 will automatically come here. So this is the result, 11, and anything less than the 11 length curve would be the entrance line. So the expression, just gonna double click here, would be x less than y. So now as a result you will have a true, false, true, false, true, false, where so the true is wherever x is less than y, and false is wherever not. So it doesn't matter if you put x less than y or x greater than y, it's going to get you same result, since either all of these entrance line will be true, or either all of these entrance lines will be false. So what we need to do to separate is again use call pattern. Remember, we are not using cull index because here we don't have the exact numbers. We have true and false, which is a pattern. But if you have the exact numbers, you can use cull pattern, which probably sometime later we will do. So sorry. So this is the cull pattern, and the list would be actually these segments here. Cool. So as you can see, we have these curves automatically selected now, and now we can move these curves and these lines into two separate levels, and then basically tell Grasshopper to smoothly connect them to create that visual effect of that, okay, the curve is going down and then again up. Now how to do that is I'm going to copy this so that I can again reverse this, and once I reverse the list, you can see all the other portions are selected. So now we have two different not portions, but list of curves for two different heights to be merged again back at the later stage. Um, so what we are going to do now is, so okay, so let's move them at two different levels here. I'm going to go to geometry. Okay, we don't need so high. So this is the entry curve, and we just need a little bit above the road. Obviously it will never be on the same level of the road, it will be just a little bit above, which would be 0.01 in this case. So okay, we need a z vector for this so that it knows that the z direction we need it to motion. Okay, cool. So now here you can see a little bit, it's 0.01 above it. Now it won't make any difference in rendering, or I mean it will make a difference in rendering in terms that it will not collide with the surface underneath. So it's again better to give 0.01, but it won't be visible. So it will look like it's almost at the same level of the road. So now the next portion we need to move it. So now the curb height could vary from 0.2, in which in centimeters is like, or millimeters is like 200 millimeters, to even sometimes it's just 100 millimeters, to sometimes I've seen 300 millimeters. So just to see here, we can keep it to 300 millimeters, which would be 0.3. And actually we can exaggerate this one so that we visually can see, and then we can reduce it later. So I'll just keep it to 0.05. Yeah, so that at least we can visually see the difference here. So now what we need to tell Grasshopper is that just easily, smoothly just merge these curves, and then that's all you need to do basically. But right now, if I say to Grasshopper that okay, we need to merge this, it will directly connect these 2 points. To create a smooth slope, we need to tell that this point needs to be connected a little bit further than the connection directly beneath it. So to do that, we are going to reparameterize this curve and basically scale it in its same direction. And I'll explain you what I'm saying is, here we need to grab this, and the first thing we have to do is evaluate curve here, and the parameter would be 0. Okay, so before I start that, let's assume that this is the curve here when we straighten it out, right? So this is the endpoints and the start points of the curve. Now to tell to Grasshopper that we need some points here and here, we need to reparameterize it, and what in this case it means is tell Grasshopper that this is 0 and this is 1 for each curve, and what we need points is somewhere between 0.2 to 0.8, right? If this is 0 and 1, so these 2 points and the line above will create then a smooth points between them. So let's do that. So I'm just gonna add a parameter 0.2. Okay, that seems okay. So what is okay? I forgot to reparameterize it so that it understands that it's exactly from 0 to 1. I'm gonna add this. Actually, maybe flatten it and then graph this so that both the values are actually multiplied with each curve. Cool. Now we have 2 points on each end. And now what we need to do is basically again make sure that these points are exactly on the curve. For that we are going to use curve closest point. The curve would be this one. And basically shatter all of these curves into 3 different parts, and we are just going to keep the middle portion of each curve so that this point connects it to this points very smoothly, and this point connects to these points very smoothly, and then again create a nice smooth curve between those. So let's do that. Let's shatter it, and the points, sorry, the parameters would be this, and the curve, I guess this one. So now let's check it. Okay, so we just have two. We need to do basically flatten it. Okay, so for each set, which is each curve, we have 3 different curves divided, and we always need the center one because we don't need the first portion, we neither need the last portion, the center portion, and the center portion is the list of 1 in each. So we are just going to go to list index, and here, and then here we are going to set 1 because from 0, 1 and 2 we need 1, which is the center one. Oh, okay, sorry, this is item index. I need a list index, list item, my bad, this is wrong. Yeah, okay, so it's by default selecting 0. We need the index to be 1. Perfect. So now you can see all the center portions are selected, and basically now we can have a smooth curve. So what we now need to tell Grasshopper is that it should remember the last sequence so that it does not by default connect this curve to this curve, but connects this curve to this bigger curve. But now they are in a separate list. So we need to weave them together, weave the list together. So we are going to use a weave command, and before that I'm just going to bring this also here so that now we have 2 lists that we need to weave. And before weaving I'm gonna check which one is actually, how is the pattern going in between those. So list item, so here this is the first curve, and here, okay, before that let me flatten it again because needs to be smooth. Okay, so the first curve is here and the first curve of this portion is here, so we need first to connect with first and then thereon the whole line. So in stream 0 and 1 the pattern is 0 1, so from each of the list it will take first 0 and then 1 0 1 0 1, so it will again weave the list together. So the 0 would be this one and then 1 would be this one. So if you see here the pattern is 0 1 0 1. You can change this pattern and sometimes you might get an error, so just come here and change the pattern and see what's what. Here I have already added a portion where you can change the pattern, but I don't think you are going to need that ever. But still, if you want to have a reference, you can go ahead and I will upload that whole scripts image down below in the description. So this is the view again. Oh, we don't need the list, sorry, we need the whole list. We are just selecting the first items. Okay, now what I need is a curve, basically a portion with smoothen curves. So polycurve, connect curves. Yeah, so I'm just gonna connect this and boom, here you have a nice smooth curves. Now again, if you need to change this bulge, which is too high, we can just go 0.5 and change this bulge here, and there you have a nice smooth curve at the entrance. And now you can go ahead and connect or extrude these lines manually to create these nice curves, uh, and detail out all the tree plantations, sitting spaces on the curb. And if not, you can just copy this whole portion and create a nice thick offset geometry from this, and that would be it for this video. So I hope you learned how to create a nice script for curve, and if once you make this, just make sure you save it somewhere on your computer, and also to tag it like I have tagged in the image, so that when you come back, it's easy to remember what you have done, and you don't get confused by it. So that's it for today. Thank you for watching.